In this lesson, we're going to be solving quadratics by factoring. By the end of this lesson, you should be able to solve quadratics using the factoring method, make connections between the zeros and the x-intercepts, and solutions to a quadratic function. Before we begin solving, let's review all the ways that we can factor. Remember that you can factor out a GCF, which is the first thing that we always want to look for. Then we have factor by grouping when there's 4 or more terms, product sum, and map when we have 3 terms. One where the coefficient of a is 1, another where a is a different number. We've got difference of squares when there's 2 terms, and a perfect square trinomial when the right conditions are met. Now, when we're solving, remember that we're using the zero product property, so we're factoring completely. We're going to set each of the factors equal to 0. We're going to solve, and then we always want to check our solutions to make sure that they are the correct ones. The real-world problems that we're going to encounter with quadratic functions that would involve solving would mainly be vertical motion problems. Our vertical motion problems are going to use the equation h of t equals negative 16t squared plus vt plus h, where v would be the velocity and h would be the initial height. Here you'd factor out a GCF, you'd factor out a -1 at the least, so that that first term is not negative, and then you would completely factor so each of the factors equal to 0 and solve. Once you've solved it, you'll have the zeros for the graph. Then you could go back and find the vertex from the equation, and you could sketch a graph so that you could answer any other information that would be needed for this. Okay, let's look at number 1. Number 1, we have part A, where we see the following polynomial, following quadratic. In order to solve this one, I'm going to start by adding 9x to both sides and subtracting 4 from both sides, as to get both sides equal to 0. When I do that, I end up with x squared plus 5x minus 6 is equal to 0. I could factor this one using product sum. We're looking for the product of -6 and the sum of +5. I know that 2 numbers that multiply to give me -6 that also add to give me 5 are -6 and 1. And so my 2 factors are x minus 6 and x plus 1. Now, when I go to solve this one, I say each of those factors equal to 0. So x minus 6 is equal to 0. X plus 1 is equal to 0. And I solve. I add 6 on both sides here. This gives me x is equal to 6. By subtracting 1 here, I get x is equal to -1. And I know that my solution is -1, 6. Now, I'm not going to check them here, but remember to go back and plug them in, substitute them back in to the original problem to make sure that you didn't make any mistakes. If we look at number 2, again, we're gonna get one side equal to 0. So by doing that, I'm going to subtract 3x squared and add 4x to both sides. I'm going to add them or combine them to the like terms. When I do that, I get I get 18x squared plus 9x minus 35 is equal to 0. Because the coefficient of a is 18, which is larger than 1, I could use guess and check, or I could use MAC. I'm going to use MAC on this one. MAC says multiply 18 to 35, multiply a and c. When I do that, I get 630. And because it's -35, that's going to give me -630. So I'm looking for the product of -630 and a sum of 9. I'm going to look for the factors of 630. Because it's negative, my factors, when they add, are really going to be subtracting. So I'm going to look for 2 numbers that subtract to give me 9. So I'm looking for my factors of 630. I could start with 1 and 630, but that's not close to 9. So I'm going to start a little bit closer to 9. Or a little bit I'm going to start with larger numbers that will give me a little bit closer to 9. So I'm going to start with 10 and 63. I know that that's 630. That gives me a little bit closer. And then I just go down the list. I try to divide it by 11, 12. The next factor I get is 14 and 45. The next one is 15 and 42. The next one is 18 and 35. and eventually I get down to 21 and 30. I know that will subtract to give me 9. Now, in order to have a positive 9, the 21 has to be negative. So it's negative 21 and 30. Then I could factor by grouping, or I could use the box. I'm going to use my box method here. In the box, my first term is 18x squared. My last term is negative 35. And then in the other two boxes is where I put my two numbers that we came up with, which is negative 21x and 30x. Then I see what I can factor out. So I look at this one, and I know that 18 and 21, I can factor out as 3x, which means that this would have to be 6x on the top here to give me 6x, to give me 18x squared. I'd have to have positive 5 here and then negative 7 here. So my two factors are 6x minus 7, 3x plus 5. I set each of these equal to 0 when I solve, so 6x minus 7 equals to 0, 3x plus 5 equals to 0. Add 7 on both sides here, that gives me 6x equals 7. Divided by 6, I get 7 over 6. Subtract 5 on this one, I get 3x equals negative 5. Divided by 3, I get negative 5 over 3. So my solution for this one is negative 5/3 and 7 over 6. These are the zeros from my graph. This would be where they cross the x-axis. Again, you always want to check your answer by plugging it back into the original equation. Don't be afraid of fractions when you're substituting them back in, because you'll have a calculator to help you with that process. Alright, the other problems that we're going to see aside from vertical motion is going to be area problems. So if we look at this first one, I know that the area of a rectangle is area equals bh. So I'm going to plug in, substitute in what I know. I know that the area of this rectangle is 234. I know the base is 2x minus 8. And I know that the height is x. What I'm going to do is I'm going to multiply first. Then I'm going to get everything on one side, and then I'll factor it. When we want to solve questions like this, we solve them by factoring. So I distribute the x. It gives me 2x squared minus 8x equals to 234. I'm going to subtract 234 to get everything on one side, and then I'm going to rewrite it so that's 2x squared minus 8x minus 234. Now, again, because this coefficient is larger than 1, for a, I'm going to use math. So I'm going to be looking for a product of 468, negative 468, and a sum of negative 8. Again, I'm going to be looking for two numbers that multiply to give me 468, but are going to subtract to give me 8, since it's a negative factor here. Alright, so when I'm looking, I have one. I could start again with 1 and 468, but I need numbers that are close to 8. So I may start with 9 as I'm going down. 9 and 52. Then the next factor would be 12 and 39. 13 and 36. I'm getting closer. And then I see, hey, 18 and 26 are 8 numbers apart. Again, negative 26 this time because they have to add to give me negative 8. Alright, so once I have that piece, I'm going to factor. I'm going to use my box. Okay, and the top of my box goes 2x. The bottom is negative 234, so A and C go in these two boxes. My other two numbers that we came up with, which were negative 26x and 18x, go here. I look for my GCF amongst 2 and 26 as 2x. I look for my factors between, that's x squared. I look for my factors between, so that would mean that x would have to go here, 18 would have to go here, and 13, negative 13, would have to go here to give me the values inside the table. Alright, so my two factors are 2x plus 18, x minus 13 equals to 0. I said each of them equal to 0, so 2x plus 18 equals to 0, x minus 13 equals to 0. Alright, subtract 18 on both sides, I get 2x equals negative 18. x equals to negative 9. And then here I'm adding 13, so x equals 13. And so my two solutions are negative 9 and 13. However, negative 9 is not reasonable because I cannot have negative side lengths, cannot have negative dimensions. For setting up the triangle one, again, it's the same process. This time the area of the triangle is 1/2. Based on its height, I fill in what I know, so I know that I have an area of 150. 1/2 my base, which is 2x plus 1, times my height, which is x. Again, I'm going to multiply, so I'm going to go ahead and multiply the polynomials here. This is 1/2. 2x squared plus x equals 150. Distribute the 1/2. This gives me x squared plus 1/2 x. Because I don't want to deal with the fraction here, I'm going to multiply everything by 2, both sides. This becomes 300 equals 2x squared plus x. Subtract 300 on both sides so that everything, so that one side is equal to 0. This gives me 2x squared plus x minus 300 equals to 0. Again, I'd use product sum here. Mac. So I'm looking for a product of negative 300, negative 600, negative 600, and I'm looking for a sum of 1. As I go through and I look at my factors again, I'm listing them, I find that 24 and 25 work. 24 has to be the one that's negative since I need a positive 1. Put the stuff into my box. Again, 2x squared goes in the first box, 300, and then negative 24, x and 25x. And then I pull out a 2x from here because that's the GCF between 2x squared and 24x. That means x has to go here, negative 12 has to go there, and 25 needs to go here, so that I end up with 25x. My two factors are 2x plus 25 and x minus 12. If I set each one equal to 0, I'm going to get 2x is equal to negative 25, or x equals negative 25 over 2. Here I'm going to get x is equal to 12. My solutions are negative 25 over 2 and positive 12. But again, for the same reason as the last one, I can't have a negative length. So I have a positive 12. It's the only dimension that works. All right. We're finding the value of k when we know that one of the solutions is negative 2. So when I'm listing out, when I'm factoring, okay, I know that my factors are in binomials. X squared, so I know that because this is x squared, I know that both of my first terms need to be x. My solution is negative 2, one of them is. And the only way to have gotten negative 2 is if I subtracted 2 on both sides. So if I know that x equals negative 2 is one of my solutions, if I undid that work, I would get x plus 2 is equal to 0. So I know that one of my factors is x plus 2. The only other number that would multiply to give me negative 16 would be a negative 8. And so I know that the value of my other solution is not negative 8. My factor is negative 8. My other solution would be positive 8. So you're doing the opposite of the factor and the solution would be opposites of each other. So my other solution is positive 8. And to find the value of k, I would FOIL to give me x squared minus 8x plus 2x minus 16. And the middle combines to negative 6x. So I get x squared minus 6x minus 16. So k, in this case, is 6, since we already have the minus sign here. Again, vertical motion problems. We're using the formula negative 16t squared plus bt plus h. It wants to know, and we're given a ball thrown vertically upward at the top of a building the initial, that's 96 feet tall, with an initial velocity of 80 feet squared. So on this one, if I want to figure out when it would strike the ground would be at 0. That would be my ending height, negative 16t squared, plus my initial velocity, which was 80 t, plus my initial height, which is 96. Again, when I want to solve this one, I would factor. So I'm going to factor out a GCF. I can pull out a negative 16t from all of these terms, or not negative 16t. I can pull out a negative 16 from all three of these terms. This would leave me with positive t squared minus 5t minus 6. Again, I want to factor out. That negative. All right, when I go to factor this, if I use product sum, I would figure out that my two factors are t minus 6 and t plus 1. I go to set each one of them equal to 0. I get t is equal to positive 6 in this one. T is equal to negative 1 in this one. Since I can't have negative time, my time that it took to strike the ground is 6 seconds. Again, you want to factor out a negative 16 so that that t term, or a negative value, so that that first term becomes positive. After how many seconds would it reach its maximum height? Well, I would take my equation right here, and I would find the vertex using what we did with standard form, which is using the axis of symmetry to find that. Reasonable domain or range for this problem. For the domain, it can't go on forever. We start at 0 seconds. We end at 6 seconds. So my domain would be 0 to 6. Or, as an inequality, x is greater than or equal to 0. Less than or equal to 6. For my max, or for my range, we're talking about its height. The lowest height it got was 0. The highest height it got was its maximum. So once you identify the vertex, you can find that maximum height. This is how we solve quadratics by factoring.